Welcome to the lesson Working and Reverse Designing. In this lesson, we will understand the working of final circuit with the concepts we saw in the previous lessons. Then we will also understand how we can design the circuit with more accuracy in next few lessons. So here we go. This is the final circuit of over and under voltage protection. This is to be connected to my refrigerator like this. Now let's understand how this is operating. This is the AC main supply, which is 230 volt and 50 Hz according to Asian standard. Now I have connected a step down transformer which is converting 230 volt to 36 volt AC. Now I connected a bridge wave rectifier which is converting this 36 volt AC into pulsating DC. Then I have some filtering circuits which converts the pulsating signal into a low ripple which is near DC signal of 18 volts. But the supply of comparator IC requires only 12 volt and that too a pure DC voltage. So hence I need a voltage regulator of 7812 to get pure DC. Then I fade this output to comparator IC, but relay only requires 5 volt, so I use another voltage regulator made up of Zener diode which gives a constant voltage of 5 volts. Now I need to evaluate the fluctuations in the main supply, which is our main aim actually. Now understand this. I used two comparators from LM324, of which non-inverting input of first one is set to a reference value using a Zener diode and inverting value of second one is set to a lesser reference value. Now I divided the voltages here at to some intermediate value in between 4.7 volt and 5.6 volt, which are my reference voltages. Whenever the supply voltage goes low, then the voltage at filter's output will also goes low and it may be decreased to a value which is less than 4.7 volt. Then comparator 2 will give the high output of 12 volt and relay get activated because of BJT will provide a sufficient amount of current to it. Hence the circuit of refrigerator connected in output will be switched off. Hence protection against overvoltage is achieved. Now if supply goes high and voltage at the output of filter get increased, then the output of the voltage divider will also increased. If the increased voltage go beyond 5.6 volt reference, then comparator first will give high output of 12 volt and again and the relay get activated and refrigerator switches off. Now what will happen if voltage is neither under nor over? Then it means it is in safe range. Then the divider value here will be in between the reference voltages and output of both the comparators will be 0 volt. Hence because there is no output in the comparator, so there is no input for switching circuit, hence it will not active and refrigerator circuit remain connected and refrigerator will remain on. During next 3 lessons, we will design this circuit in 3 different blocks, which are step down block, comparison block and switching block. We will design this circuit in reverse direction so that you can understand it better and decide the right value of comparators. So I'm assigning block 1 to switching block, block 2 to comparison block and block 3 to step down block. So let's come and design this circuit. See you in the next lesson.